Hi, my name is Mario. I'm one of the developers of Libgdx. In this video we're going to talk about how to set up your development environment for Eclipse or IntelliJ, how to create a Libgdx project, import it, then run it and debug it. We are currently on a GitHub page of Libgdx. We have a lot of links here and we have a wiki. I suggest that you are reading all of the content of that wiki to get to know Libgdx. That being said, let's see how we can set up our development environment. Libgdx projects are based on Cradle, which is a build and dependency management system, and also helps us with IDE integration. You do not necessarily have to know Cradle, but it helps if you want to do something special. Otherwise, you can completely ignore the Cradle portion of Libgdx. To use Libgdx with Eclipse, you need the following things installed. You need to get the Java Development Kit, you need to get Eclipse, you need to get the Android SDK. Don't get the ADD bundle, which includes Eclipse, but just the SDK. Once you install the SDK, fire up the SDK manager and then install all the platforms. Then you have to install the ADD plugin for Eclipse using this update URL. And you need to install the Eclipse Cradle integration from this update site. If you want to target iOS, you also need a Mac. We cannot work around this issue at the moment. And you need the latest Xcode, which you can get for free from the App Store, as well as the RoboVM plugin for Eclipse. Make sure to update that because RoboVM is changing constantly. For IntelliJ IDEA, the story is pretty similar. You need the JDK, you need the latest version of IntelliJ IDEA. We support 13 and upwards. The community edition is sufficient. And we need the Android SDK. Again, don't download the bundle, just get the SDK, install it, fire up the SDK manager, and install all the platforms. For iOS development, you again need a Mac and you need to install Xcode. So once you have all of this installed, you can create your first Libgdx project. Creating your first project is pretty simple. All you need to do is download this jar file, which is a Swing application which will generate your Libgdx project for you. So let's just do that. Yes, open it. The Swing application lets you specify the name of your application, the package under which your code should live, the name of the main or game class, as well as the destination where the project should be generated to. We generated to the downloads folder into a subfolder called test, so let's do this. Everything went fine. The tool also tells you how to import it into Eclipse and IntelliJ. So let's see how we can import it into Eclipse. Importing your project into Eclipse is really simple. Just go to File, Import, Cradle and Cradle Project. Then navigate to the place where you created your project and say Build Model. This will check which projects have been defined in your Build Cradle definition. So we found a couple of projects and those we want to import into Eclipse. The integration will now generate Eclipse projects and import those into your workspace. The first time you do this, this might take a little longer, as there is a couple of things that would usually get downloaded on first try. So as you can see, the projects are now imported one by one, and we should be done by now. Okay, so now let's see what kind of projects we have. We have the core project, which contains all of our source code. In this case, it's a simple application which just loads the texture and draws it to its screen. For each platform, we then have launcher projects. For the desktop, we have one, which instantiates the game and then runs it on a desktop. We have the same for Android. And we have the same for GWT or HTML5. And we have the same for iOS. So to run the project on a platform, we just right-click on the platform project and say Run As, and then whatever fits. For a desktop, we have Run As Java application. This will run the project on a desktop. The problem is to where our art assets are. And as you can see, the application fails launching because it can't find the BadLogic JPEG file. This is because the working directory has to be the Android project's assets file. This is for historical reasons. The Android project can only be built if the assets file is within the Android project. So all other projects depend on this assets directory and fetch the graphics from there. So to fix this for the desktop project, we just go to the Run Configurations, say arguments, and set the working directory to other workspace Android assets. So from there on, the desktop project will be directory, and then it can find all the assets. Running all the other platforms works pretty much the same. For Android, we just right-click and say Run as Android application. I won't do this here. For iOS, it's the same, right-click, Run as, and then we have a couple of choices. iOS device, which is when you have an iPad or iPhone connected to your Mac. You need to have a provisioning profile for that, which costs you $90 because you need a developer license. You can find more information on that on our wiki. You can also run it on a simulator. This is free. So let's run it on the iPhone simulator. The first time you build your iOS project, RoboVM has to pretty much compile the world. So this will take a while. Subsequent compiles like this one take a lot less time. It's usually in around 10 seconds until you got your application deployed to your iOS simulator. So as you can see, we have now spun up an iOS simulator and our application is running on iOS. GWT is special. As we compile Java to JavaScript, we first have a compilation step, and then we have to serve the HTML, CSS, and JavaScript files. We created a Gradle task called superdev, which invokes the GWT superdev mode, which does all of this fancy stuff for us in the background. So let's try to run our application in the browser. For this, we right-click the GWT project, say Run as Gradle build, because we want to execute a Gradle task. There we select the superdev task, which is the one I just described. And that's all fine. And then we just say run. And what's happening now is that the project is being compiled to JavaScript. It is then served by an embedded Jetty server on the localhost port 8080/GWT. So we can go to localhost 8080 GWT. It hasn't started up yet, we have to wait a little. Compilation of GWT takes quite a while, that's why we're using draft compile. You basically start this once and then you can develop and don't have to restart it, you just leave it running. So now our site has started, and as you can see, here's our application in GWT. Now what's happening in the background is we are also firing up a so-called code server. As you saw, compilation to GWT takes a long time, so what we want is every time we change something in our Java code, say the background color, we want this change to be reflected here more quicker than 30 seconds. So what we can do is we can use the super development mode. There's a separate server running at 9876, and we take this bookmarklet, and then we go back here. We only have to grab this bookmarklet once, you have to never go there again. And then you click on dev mode compile. And what's happening now is the Java code which is changed is recompiled in the background, as you can see, and then re-injected into our website. And this only took like 7 seconds. It usually takes less, but I'm currently on battery, so not at 100% CPU. And that's how you run your projects on all the different platforms. Since we are already in the browser version of our project, I can show you how you debug your browser version of your project. This is a nicety you have to do. superdev mode, you just right-click in Chrome and say Inspect Element. Then you go to Sources, and then localhost, source maps. Make this bigger. And as you can see, you have packages here, Java packages. So we can actually go to our Libgdx game and set a breakpoint in the browser without any Java applet plugins or anything. Then we can just debug this. You can also check out local variables and so on and so forth. That's how you debug your GWT project. Okay, so the last thing I want to show you for Eclipse is how you debug your projects, and that's really just the same. Right-click on a project instead of run as, say debug as, and your project starts in debug mode. Let's see. Yes. And that's it. Importing into IntelliJ is pretty simple as well. Just open up IntelliJ and then say import project. Next, you navigate to the folder of your project and select the build Cradle file in the root of your project. In this dialog, you just leave the settings as they are and click OK. Now IntelliJ will create IntelliJ projects from your Cradle definition and import them to IntelliJ. This can take a while first time because you have to download dependencies and Cradle if they haven't been downloaded yet. Also, the first time your project gets imported into IntelliJ, the Cradle tasks that assemble the individual projects are executed, which may take quite a while. You can see the progress down here. And as you can see, it's now compiling all of the projects. We can stop this task. Okay, now that we have imported our project, we can create run configurations. First thing we want to start is the desktop project. So we go to Run, Edit Configurations, click the plus, say Application, because we want to start a desktop application. And we give it a name, that's called Desktop. We set the module to Desktop, and then the main class to Desktop Launcher. We also have to set the working directory to the Android project's assets directory, as this is where our application's assets are located. And this is how we configure our desktop configuration. Hit apply and OK. And if we now click on the desktop configuration and say run, the project will be compiled via Cradle, and the desktop variant of the project will be started. For Android, we do something similar. IntelliJ already created a configuration for us, which is called Android. If you click on the play button, then the Android APK will be compiled from the application, and an emulator or device will be used to deploy and run the application. As you can see in the background, Cradle is used again. I skipped this step as I have no device connected and no emulator started. To run the iOS project, we create another run configuration. This time it's a Cradle run configuration. We give it a name. We say which Cradle project to execute. It's the iOS project in this case. And the task. For iOS, there are three Cradle tasks that are relevant here. Launch iPhone simulator will launch your application on the iPhone simulator. Launch iPad simulator will launch your application on the iPad simulator, and launch iOS device will launch your application on an iOS device. We want to launch it on the iPhone simulator, so we'll remove the other tasks and hit apply. OK. Now we can select the iOS configuration and say start. This will now call the Cradle task, which compiles the iOS project, creates an iPhone simulator compatible native file, and then deploys it to our iPhone simulator. This can take a while on the first try because RoboVM has to compile a lot of files, especially those of the runtime library classes. And here we see our application running on the iPhone simulator. Finally, we want to run our application on the web as a JavaScript application, so we want to execute the GWT project. Just like with the iOS project, we create a new configuration. Again, we create a Cradle configuration. We give it a name, let's call it web. We select the Cradle project, which is GWT, and the task is the SuperDef task, which will start the application for the web in SuperDef mode. Now we can hit run. And this will now compile our application from Java to JavaScript via the GWT compiler. It then takes this JavaScript plus HTML and our assets and creates a web application that it serves on localhost 8080/GWT. The compilation task takes quite a while, so we generally just start this up once and then leave it running. we can then use browser commands to recompile our application directly in the browser. So now that the code server is ready, we can go to Chrome and navigate to localhost 8080 GWT. This is now serving up our application as a JavaScript application. If we want to recompile our application quickly, we can go to the code server address and drag this dev mode bookmarklet onto our address bar. You only have to do this once. So now let's say we change our code. Let's say we change the background color to red. Then we can go back to the browser, hit the dev mode bookmarklet, say compile. It's getting compiled in the background. And once it's done compiling, it's restarted in the browser. Debugging this project is the same as we saw in Eclipse. We right-click, inspect element, into sources, and then we see our Java source and can set breakpoints. Debugging the other projects works the same, except for iOS, which doesn't support debugging. You just select the configuration and then hit the debug symbol. And that's it. If you want to know more, just go to our website, libgdx.badlogicgames.com, or go to our GitHub page, which is at github.libgdx. See ya.